this is lecture 11 of our subject digital system design, and the topic for today's lecture is multiplexers and demultiplexers. So, these are the contents of today's lecture. We will first we will be covering the concept of multiplexing, and then how this multiplexer can be used to design the circuits, and how the next subtopic will be this one, in which we will see that how we can use smaller multiplexer to realize a higher size multiplexer. Similarly, then we will proceed to the concept of demultiplexer and how this demultiplexer concept can be used to realize a higher size demultiplexer using some lower size demultiplexers. Okay. So, let us start with the concept of multiplexer. So, multiplexer, it is a combinational circuit. Okay. It has multiple inputs 2 raised to power n, as can be seen from its block level representation. So, there are 2 raised to power n inputs for n select lines. It is mentioned here for n select lines. So, these are n select lines, and for these n select lines there are 2 raised to power n inputs, and the output is a single one. That means, these n select lines will be selecting one of these 2 raised to power n possible inputs, and that selected input will be connected to the output. So, input will be connected to output, but which input will be connected to output, it will be decided by these n select lines. Okay. So, this is the concept of multiplexing. So, let us put n is equal to 1, it will be the smallest possible multiplexer. So, if you put n is equal to 1, that means there is a single select line, one select line, and for one select line we can see that 2 raised to power 1, that means there are 2 inputs. So, that is why it is mentioned 2 cross 1 multiplexer. So, we can mention it here if these are the positional weights of these inputs. So, 0 and 1. So, if you apply 0 here, then this I naught will be connected to the output. Okay. As you can see from the truth table, if you place S naught is equal to 0, then Y will be equal to I naught. Similarly, if you place S naught is equal to 1, then this I 1 will be connected to Y. As you can see, if S naught is equal to 1, then this Y output is equal to I 1. So, this is the concept of smallest possible multiplexer, that is 2 cross 1 multiplexer. Similarly, we can have a 4 cross 1 multiplexer if we are having 2 select lines. So, we can see that there are 2 select lines, and for these 2 select lines there are 2 raised to power 2, 2 raised to power 2, that means 4 inputs are there, which can be labeled as 0, 1, 2 and 3, and there is a single output Y. Okay. So, from the truth table we can see that if we apply 0, 0, 0, 0 corresponds to 0 in decimal. So, that is why this 0 position is selected and it is connected to the output, that means Y is equal to I naught. Similarly, if I place S 1 is equal to 0 and S naught is equal to 1, that means if 0, 1 are placed on these select lines, then this 1 will be selected and connected to the output. Similarly, for 1 0 I will be getting I 2 at the output, and for 1 1 I will be getting I 3 at the output. So, these are the expressions, these are the selected inputs which are made available at the output by the help of select lines. Okay. So, if you want to write the expression for this Y multiplexer output, we can see that S 1 is equal to 0, S naught is equal to 0, that means S 1 bar, S naught bar, this is the main term, S 1 bar, S naught bar into I naught. So, this is S 1 bar, S naught bar into I naught. Similarly, for this second row, S 1 is equal to 0, S naught is equal to 1, that means S 1 bar, S naught into I 1. So, S 1 bar, S naught into I 1. Similarly, for this third row, you can see that S 1, S naught bar, S 1, S naught bar into I 2. Similarly, for this last one, we can have S 1, S naught into I 3, S 1, S naught into I 3. Okay. So, this is the expression for this Y output, and all these 4 expressions obtained from 4 rows are added together to give me a single output Y. So, if you want to realize circuit for this Y, we can do it very easily by placing the select lines S 1, S naught, and this will be S 1 bar, this will be S naught bar. Okay. Then we can realize the first product S 1 bar, S naught bar into I naught. So, this is S 1 bar, this is S naught bar, and this will be I naught. Okay. So, this is the first product. Similarly, the second product says S 1 bar S naught. So, this is S 1 bar, this is S naught, and this is I 1. Okay. Similarly, proceeding further, third product S 1 S naught bar. So, this is S 1, this is S naught bar into I 2. Okay. Then last one S 1 S naught into I 3. So, all these 4 products will be added together with the help of an OR gate to give me the expression for y. Okay. So, this is the circuit for 4 cross 1 multiplexer, internal structure of a 4 cross 1 multiplexer. Okay. Similarly, we can go for higher size multiplexers, 8 cross 1 multiplexers, 16 cross 1 multiplexers. So, this is about the internal circuit of a multiplexer. So, now let us come to the application part of this multiplexer, how this multiplexer can be used to realize various circuits. Okay. So, design a mux based circuit for the following expression 1, 2, 3, 6, 7. So, these are the minterms provided to me. That means, whenever I want to realize a circuit using multiplexer, my requirement is I should be having the minterms. Okay. So, these are the minterms, and how to choose the multiplexer size. If examiner has not mentioned to me which multiplexer is to be used, then this is the rule for choosing the multiplexer size. Number of select lines should be equal to the number of variables. As we can see that there are 3 variables. So, I will be using that multiplexer which is having 3 select lines. So, the multiplexer with 3 select lines, we can say that S 2, S 1, S naught, which will be actually equivalent to A, B and C in our case. Okay. So, for these 3 select lines, there will be 8 inputs 0, 1, 2, 3, 4, 5, 6 and 7, and there will be single output y. Okay. So, how to proceed about the circuit for this particular question? We have to simply connect these minterms. This expression shows that these 1, 2, 3, 6, 7, these minterms are high minterms. Okay. These minterms are giving me high output. So, simply choosing 1, 2, 3, 6, 7. So, this 1, this 2, this 3, this 6 and 7, all 5 are separated out. Okay. And they are connected to logic 1. Okay. They are connected to logic 1. Similarly, the remaining terms, that is 0s, 4 and 5. So, these 0, 4 and 5, they can be connected to logic 0. Okay. So, this is the simplest realization of a 3 variable problem using an 8 cross 1 multiplexer. Similarly, I can realize a 4 variable problem using a 16 cross 1 multiplexer. Okay. So, this is a 4 variable problem for which I am provided with the minterms. So, this can be easily realized using a 16 cross 1 multiplexer, but if the examiner asks me to realize such a problem with a lesser size multiplexer, that is an 8 cross 1 multiplexer. So, now I have to ensure that there are 4 variables A, B, C and D, but the select lines are 3. So, that means one of the select line has to be eliminated. Okay. Either we can eliminate any one of these, but it is convenient generally to eliminate either the LSB or the MSB. So, let us say if we want to eliminate the LSB. So, if you want to eliminate the LSB, so A has been eliminated and B, C and D, these are the 3 variables which are going to be used as select lines. So, I am marking these as B, C and D, and B, C, D can have 8 values, 8 set of values 000, 001, 010, 011, 100, 101, 110 and 111. Okay. So, these are the 8 set of values, and A and B, the select line which is eliminated, can have 2 values 0 and 1. So, if we study from A to A, B, C, D, these cell numbers can be labeled as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Okay. So, the terms which are provided to me as the high min terms, they can be fed into this structure as 1, 2, 6, 7. So, this is 1, this is 2, this is 6, this is 7, then 8, then 12, 14 and 15, 12, 14 and 15. Okay. So, now we have to use this structure to find the connection for the input side. It is very much clear that if BCD is equal to 000, then I naught will be selected. Similarly, for 001, I1 will be selected. Similarly, I2, I3, I4, I5, I6, I7. Okay. Checking this I naught column, I can see that there is a single one which corresponds to A is equal to 1. That means, I naught should be connected to A. Similarly, I1 is having a single one which corresponds to A is equal to 0. That means, it must be connected to A bar. Similarly, this is similar to the previous one. So, it will also be connected to A bar. There is no one in this column, that means, this I3 will be connected to 0. Again, there is a single one, that means, which should be connected to A. Similarly, there is no high term, that means, it should be connected to 0. Then there are 2 high values, that means, A bar plus A, that means, this should be connected to 1, and similarly there are 2 ones there as well. So, this should also be connected to 1. Okay. So, in this way we have generated the connections, and we can implement these connections here. So, if we use, first I am realizing this A, I3 and I5. So, for this I am labeling these connections 0, 1, 2, 3, 4, 5, 6 and 7. This is my Y. So, I3 and I5 are 0. So, I3 and I5 both are logic 0. Okay. Then I can check that I6 and I7 are 1. So, this I6 and I7 both are logic 1. Then I can check A. So, there are 2 connections for A, I naught and I4. So, this I naught and I4, these are connected to A. Okay. Then we can see that I1 and I2 are to be connected with A bar. So, A bar we have to generate first, and they are to be connected with this 1 and 2. So, this is the connection pattern for the input side of the 8 inputs of an 8 cross 1 multiplexer. So, in this way we can realize any expression using a multiplexer or a size lesser than that multiplexer. Similarly, this circuit could have been realized using a 4 cross 1 multiplexer as well. In that case, we would have eliminated 2 select lines A and B, and A and B would have been placed here, C and D would have been used to select the 4 inputs of the 4 cross 1 multiplexer. Okay. So, this is the circuit realization using multiplexer. Okay. Now, let us come to the realization of higher size multiplexer using lower size multiplexers. Okay. So, an 8 cross 1, we are asked to realize an 8 cross 1 multiplexer using 4 cross 1 multiplexer and 2 cross 1 multiplexer. So, we can choose any one. So, to realize this, first we have to complete the number of inputs. So, there are 4 inputs, there are 8 inputs and 4 inputs. That means, minimum 2 4 cross 1 multiplexers are going to be used. So, I am using 2 4 cross 1 multiplexers. Okay. So, 4 cross 1, 4 cross 1, 0, 1, 2, 3, 0, 1, 2 and 3. So, these are the 4 inputs each of these 4 cross 1 multiplexers. I am labeling the outputs as Y1 and Y2, okay, because I need only one output, but there are 2 outputs Y1 and Y2. So, they have to be clubbed together by using some additional circuit. That additional circuit can be an OR gate or another smaller multiplexer, 2 cross 1 multiplexer. First I am labeling the inputs as I 0, I 1, I 2, I 3. Similarly, these names can be extended to I 4, I 5, I 6 and I 7. Both of these multiplexers will be having the same select lines. Okay. And these two outputs can be further fed as inputs to another 2 cross 1 multiplexer, which will be having its own one select line. So, and it will be giving me the final output y. Okay. So, we can mark these select lines as this will be my MSB, that is S2, and these will be my two least significant select lines S1 and S0. So, this is the realization of an 8 cross 1 multiplexer using 2 4 cross 1 multiplexers, and we have used 2 4 cross 1 multiplexer and 1 2 cross 1 multiplexer. Okay. So, we have used 3 multiplexer to realize an 8 cross 1 multiplexer. Now, we can see that if we choose S2, S1, S0 is equal to 1 1 0, this 1 1 0 corresponds to 6, that means I 6 should be connected to Y. So, let us check whether we are getting this I 6 connection at Y. So, S2 is equal to 1. So, S2 is equal to 1, S1 S0 is equal to 1 0, S1 S0 is equal to 1 0. So, this 1 0 will be reaching both the multiplexers. So, for this 1 0 this I 2 will be selected, for this 1 0 this I 6 will be selected, that means it will be giving me I 2 and this will be giving me I 6. So, now this 2 cross 1 multiplexer which is having one select line, for this one will be selected, that means this I 6 will be selected and I 2 will be dropped. So, this Y will be getting I 6 at the output. Okay. So, in this way we have realized an 8 cross 1 multiplexer using these combination of 4 cross 1 and 2 cross 1 multiplexer. Similarly, if you want to realize this thing using 2 cross 1 multiplexer, then this minimum we have to use 2 cross 1 multiplexers into. So, this will be the structure, these two will be further fed into another 2 cross 1 multiplexer, which will be having the common select line, and another 2 cross 1 multiplexer for the final output. Okay. So, this will be S2, this will be S1 and this will be S0, and these will be my inputs I 0 to I 7. So, this will be the realization of an 8 cross 1 multiplexer using 2 cross 1 multiplexers. So, all in all 7 2 cross 1 multiplexers are used to realize an 8 cross 1 multiplexer. Okay. So, now let us come to the concept of demultiplexers. Okay. So, like multiplexers, demultiplexers are also the combination circuits which act like the reverse of multiplexers. Okay. Multiplexers were having multiple inputs, but demultiplexers are having multiple outputs, but the behavior is identical. One of the in multiplexers one of the input was selected, and in case of this demultiplexer one of the output will be selected, but the flow will be still the same. Thus, in multiplexer the selected input was connected to the output, but in case of demultiplexer to the selected output my single input will be connected, and this selection will be done with the help of select lines. Okay. So, we have mentioned it here, it is also a combinational circuit, it has multiple outputs 2 raised to power n, and these two out of these 2 raised to power n outputs, one of the output will be selected by using the select lines, one of the output is selected, and this selection is done with the help of select lines, and there are n select lines. Selection of the output depends on the values applied at the selection lines, which are n in number. Okay. So, similar to the one which we have covered in the multiplexer case, we can see that if we put n is equal to 2, then we can realize a 1 cross 4 demultiplexer. So, 0, 1, 2 and 3, and there are 2 select lines. For 2 select lines there are these 4 outputs. Okay. So, how to study the behavior of this demultiplexer? We can check that this S1 and S0, if they are 0 0, then Y naught will be selected, and this Y naught will be connected to my input, which is I. Similarly, for 0 1, Y 1 will be selected and it will be connected to I. Similarly, for 1 0, Y 2 will be selected and it will be connected to I. Similarly, for 1 1, Y 3 will be selected and it will be connected to I. So, at a time only one of the output will be selected and it will be connected to the input. Okay. So, but this thing we have to ensure that the input must be high, so that we are able to recognize that the selection has been done appropriately, because rest of the outputs are already low. So, if this I is also equal to 0, then all the outputs will be having 0, that in that case it will not be clearly showing which of the particular output is getting selected for that particular selection line value. Okay. So, we have to ensure that I is equal to 1. Okay. So, now we can check that Y 3 is giving me single high entry or single non-zero entry, for which I can write expression for Y 3 as S1 S0 into I. Similarly, for Y 2 I can check that this one corresponds to 1 0, that means S1 S0 bar into I. Similarly, for Y 1, for this I we can check that S1 bar S0, this is S1 bar S0 into I. Similarly, for this Y 0, this one S1 bar S0 bar S1 bar into S0 bar into I. Okay. So, this is how we have realized the expression for these 4 outputs, and these 4 outputs now can be converted into a circuit. So, this is S1, this is S0, and I can also be taken here, as it is going to be used for all the products. So, if we want to realize the internal circuit of this demultiplexer, we can see that Y 3 is equal to S1 S0 into I, that means this is S1, this is S0 and this is I. This actually I, for I we do not require this NOT gate. So, I am removing it. Okay. So, this I will be used directly to realize Y 3. Similarly, for Y 2 S1 S0 bar into I. So, this is S1 S0 bar into I. This is Y 2. Similarly, Y 1 is S1 bar. So, this is S1 bar, this is S0 and this is I. So, this becomes Y 1, and the last one is S1 bar S0 bar, this is S1 bar, this is S0 bar and this is I. So, this is the internal circuit of this 1 cross 4 demultiplexer. Similarly, using this concept we can realize the circuit for a 1 cross 8 demultiplexer as well. Okay. So, this is the internal, this is about the internal structure of a demultiplexer. Now, let us come to the extension of this demultiplexer. We have been asked to realize 1 cross 8 demultiplexer using 1 cross 2 demultiplexers. So, like in the case of multiplexers, we were asked to prepare 8 cross 1 multiplexer using 2 cross 1 multiplexer. So, this is the analogous part of that conversion, or we can say that construction, higher order multiplexer construction, and this is the higher order demultiplexer construction. So, let us start with that. So, we can see that we are provided with this 1 cross 2 and we have to realize in 1 cross 8 demultiplexer. Okay. So, we can easily see that minimum of 4 demultiplexers will be required. So, let us start with the reverse. We are first completing the number of outputs. Okay. So, let us take 4 demultiplexers, so these are 1 cross 2 demultiplexers. So these will be the outputs which can be labeled as 0 1 from inside, and outside we can have any names. We can name them as per our convenience, as we are designing an 8 cross 1. So, I am naming them as they would have been named for 8 cross 1 demultiplexer. Okay. So, this is the select line S naught, this is LSB. This thing we have to remember, that in case of multiplexer, on the extreme right side we were having the multiplexer with the most significant select line, but in case of demultiplexer we will be having the least significant select line on the extreme right. Okay. So, these will be having 4 inputs, separate inputs, but we have to realize only one input. Okay. So, for that we will be further using 1 cross 2 demultiplexers. Okay. With again the same labeling and a common select line which will be S1, and again there will be 2 inputs. So, these are the inputs. Okay. Again now the inputs have reduced to 2, but I need only 1. So, I will be using another 1 cross 2 demultiplexer, which will be having one input. This will be my input I, and this will be having select line which will be the most significant S2. Okay. So, this is the internal structure, or we can say the structure of a 1 cross 8 demultiplexer, which is being realized using 7 1 cross 2 demultiplexers. Okay. Now, let us take an example. If S2, S1 and S naught would have been selected by using a particular value, let us take an example 101. So, for this 101 which is equivalent to 5, that means Y 5 should be selected. Okay. And this Y 5 should be connected to I. So, let us see whether we are getting this connection or not. So, S2 is equal to 1, S1 is equal to 0 and S naught is equal to 1. So, S2 is equal to 0, S1 is equal to 0 and S naught is equal to 1. So, for this S2 is equal to 0, we can see that this one will be selected and there will be I here and there will be 0 here, because it is not selected. Similarly, for this 0, we can see that this will be selected and this will be selected. So, this I will be passed here, sorry 101. So, this S2 is equal to 1 actually. So, this S2 is equal to 1, and let us change that value. We have put S2 is equal to 0, S1 is equal to 0 and S naught is equal to 1. So, let us take this value. For this actually 1 will be selected, 0 0 1, that means Y1 will be selected and it should be connected to I. So, let us proceed further. So, this I will be connected here, and for this we will be having a 0 here. Similarly, for this 0, this will be 0 will be placed here and it will also be 0. Then for this 1, that means this will be selected for all the demultiplexers, but this will be the only one which will be getting the I input, but all the outputs will be 0. Okay. So, this is how we can realize a 1 cross 8 demultiplexer using 7 1 cross 2 demultiplexers. Okay. Similarly, we can realize 1 cross 16 demultiplexer using some smaller size demultiplexers by appropriately first completing the number of outputs and then going backwards. So, with this we come to the end of this lecture. Thank you very much.